Okay, so we encountered 4 rock types. On the northern side, we encountered
mostly calcite,
the sedimentary calcite and sandstone. Then in the south corner, we encountered the
mostly pink
gneiss, and then we could infer that the valley was also pink gneiss down there. And then we also saw the green pluralized laser-phase rock here on top. And you can mark the contrast between the green rock here and the calcilicate here on top.
No, those are the mixture of the things.
The mixture of the two.
Have you guys seen some appealing features in terms of structure?
We've seen actually, like in terms of joints, we've seen very good conjugate sets of joints that actually displace each other. We saw like middle shears. We saw some alveolicing. What else should we see?
Orientation of life also elongated
grains. We saw
only
very strong foliation across the pink gneisses and towards the east-west direction.
mostly east orientation.
And we saw some alternative sands.
This is one of the last mushrooms.
Have you, to the rocks, have you guys managed to establish any deformation event in terms of a joint and any feature that you have encountered? These guys, were you able to establish any deformation event in terms of a joint and other features that you
Yeah,
encountered?
joints and foliation.
Okay.
Yeah.
In terms of, like you say, joint and foliation, have you managed to establish if the foliation was in tectonic, pre-tectonic, post-tectonic with respect to the growth of certain profiloblast or phenocryst?
Yep.
Okay.
Elaborate.
What this question was going on, what was the main orientation of jointing that you guys have seen in the field?
There were two common jointing directions. One first is north-south and the second is east-west.
East-west, yeah. In
The north-south direction is related to Pan-African origin. And the east-west is the
There's also observation I made, the Pan-African joints, the thickness of the joints were larger than the Namakwa, which means the Pan-African stress fields were stronger, they were more stressed, obviously because of the breakup of Gondwana and all that stuff. The extension was more in that direction.
Have you been able to see some features such as argon shaped or profiloblasts or wraparound foliations?
Yeah, in the other pink gneiss on the side.
Based on what you just told us now, what do you think? Which one was more intense in terms of
I think
the two joints that you have encountered in the area?
based on the foliation and the...
Okay, based on which one is more continuous, which one is not which one are not continuous, and yeah.
Okay, the intensity of deformation I think was stronger in the pink gneisses. We had a stronger foliation first of all. And with the alga gneisses you can see the profiloblast of the garnet in the center and the biotite right around that, which obviously tells you that the biotite, the foliation didn't overprint the profiloblasts. So it was free to synthetize.
Zay, in terms of rock types, can you broadly tell us, not about the area, but the section where you mapped? Can you just give us a brief overview of what rock types we can find here in this area? Just on the area.
Mostly it was a pink gneiss and granite. Yeah.
So when you say pink gneiss, you referring to the pinkish color in the rocks, or you just give it a name based on certain features in the area or something like that? If you say pink gneiss, did you say give it a name based on the color of certain minerals?
Based on the color in certain mineral assembly.
Okay, what was the holistically? What was the abundant mineral in that technique that you saw?
There's garnet and K-feldspar. Yeah.
Okay. What were garnet and K-feldspar easier to identify on the field, or you needed to use Excel tools to
No,
magnify?
Yeah, they
The
were
view.
easier. They were easier to identify.
Can you, by using your hands, can you tell us the size of a certain, of the biggest porphyroblasts or phenocryst that you've seen?
For instance, K-feldspar, I can say the size ranges from 2 millimeters to 5 millimeters.
And the garnet?
The garnet maybe, well, it was huge. No, the garnet was
Can you use your hands to maybe show us?
No, the garnet was like around like this, maybe 3 millimeters.
In diameter?
Yeah, in diameter.
No. Okay, guys, what are other appealing features that you've seen?
Okay. One thing that I noticed was in the Namakwa Natal metamorphic complex, most of the metamorphic rocks contained cordierite, which is actually semi-precious metal. But it was in very small quantities, unfortunately. So it had that bluish color, and you could identify it by its vitreous luster and its cubic system and its high
Only visible by the hand lens.
iron lens, and you could see the white streak also. So you knew that was cordierite, which was very interesting to see, and it's very beautiful mineral as well, that bluish color. I was actually disputing with Prof from David Donker, because he was convinced it was actually azurite, but I don't buy that. I think it was cordierite.
Because it is specifically known to have fallen in the Namakwa province.
Some point you mentioned that it might be blue parts as well.
Yeah, azurite, like a blue variety of gold.
And also again, we were talking about the
Okay,
reflectivity
Andy,
of light.
tell me, based on what they taught you in class, before you come to the field, were you confident enough to stand on your opinion, saying if I saw cordierite, I would say it's cordierite, although my professor say it's something else? Were you that confident?
The only confidence I had was I had this book that helped me. So this book actually confirmed that cordierite is found within the Namakwa metamorphic complex. So it wasn't my own confidence, it was the book.
Let me rephrase the question for Andy again. Andy, my question is, were you comfortable to relate what you learned in class and what you've seen in the field?
It's actually, for me personally, it's actually not that easy to determine the minerals. Yeah, the common minerals like feldspar, quartz, and but then minerals like cordierite and stuff, you're kind.
The problem is we were never actually introduced to these other minerals. We were only taught the most common rock forming minerals.
Yeah.
So we are experts in quartz, feldspar, and biotite. But when it comes to minerals, like other uncommon minerals, then we struggle.
Okay, Amy, can I please talk to you? Are you finding it easy to recall the information on the field and come plot the map as you're doing right now, or are you finding it more challenging in terms of you don't understand what you're doing, you're just doing it for the sake of completing your work?
The first day I was lost, but if I had like Dr. Bailey or a prof, then it's easier. Then they can leave us alone, then we can do it on our own. But if they just throw us into the field, then I don't know what to do. But mapping and cross sections is fine.
Okay. Andy, is this field this mapping technique actually, did it come to your expectation? Were you expecting it to be more difficult or lesser to advantage, or in the rate of 1 to 10, how can you rate it?
It was okay, but then the one thing that kind of confused us was the fact that we were taken to one place yesterday, and we thought we were going to map the whole area that we were given yesterday, but then again we were taken to a different area in which we didn't do much in the first area we were given at first. So, yeah.
Okay, my opinion was like, I feel that we are quite confident in mapping, like we know how to map, you know.
Yeah.
So it was for me more important to be introduced to a variety of metamorphic rocks, because I've never been exposed to metamorphic rocks. I've never seen metamorphic rocks prior to this field trip. So it was, for me, it was better for them not to just give us one area and tell us to map. So we had maybe like 1 or 2 types of metamorphic rocks. I feel like I already had that skills to map. So it was more beneficial for me to, even if I just partially map one area, but then go into another area and see more metamorphic rocks. Because I think metamorphic rocks are like the type of rocks that we've been exposed the least amount of time to.
It's always been sedimentary rocks.
It's always been sedimentary rocks.
Okay, Moisin, I'll ask you this question. Like your group member just said that you expected to map one area and surprisingly they swapped you around. So in your expectation, you thought of completing the mapping of one particular area, and but you had to map 2 different areas that are far apart from one another.
Yeah.
So were you able to adapt to the conditions, or the condition affected you badly?
First of all, I first thought we were going to get at least 3 days to map one area, like it was for the first 2 field schools. Then as time really constrained us, we only had 1 day in the field yesterday, which we barely mapped, and then today we finally mapped another area. Basically only a few hours in that area, the second area. So it's kind of very hard trying to map both areas because you're limited by the amount of information you can actually find in that amount of time. So it's quite confusing.
Okay, Amy, tell us, as a female, did you adapt easily? And the second question is, did you gel well working with male, let's say individual group members in your group? Having like the males in your group as group members?
As a female,
Yeah, on the field.
like first day, if you are fit, then obviously for anybody it's going to be hard climbing up and down, but it wasn't bad. And working with men is fine, because then you make new friendships with people you already know your friends with.
Okay, were you up to speed with what was going on the field, or you felt like you were left behind in some way?
No, I didn't feel it. Yeah,
So that you can be
Okay, you didn't feel left behind. Okay, Rachel, I'll ask you the same question. One in the field, you had you had different group members. Some of them were males, and the others were female, like yourself. So I heard that the conditions changed. Like you were mapping one area and they had to swap you around.
Yeah.
So based on my understanding, it's that when you come on mapping an area in the first day, you can allocate yourself on the map and then see like how can I make the traverses based on the topography, and you know if I have to climb mountains and stuff like that. So the first day you don't do much.
Yeah.
You just organize yourself how you can go about it. Yeah, like I understand that on that light you didn't get much information on the first day. So how did you feel when you plan on mapping that area extensively, and the next day they just tell you, no, you're not going there anymore, you have to go to another location? Did you adapt easily as a female?
No, I didn't. That's what I said in the first place, that I thought that the whole thing was rushed and unorganized, because it just proved that at the moment they said we must swap it. Because in my mind I was already busy preparing to map the, what is this called, the Pink Nice liquor drink.
Okay.
And all of a sudden now I'm in another place where there is a contact between the liquor drink and the oorkrat. You see? So everything was a bit mixed up for me. And it took me time to actually identify where I was and find my way out of that.
Okay, just tell me, how many were you in a group?
We were 5.
You were 5. How many females and how many males?
It was just to me and Zay.
You and Zay.
Yeah.
Oh, okay. How did you find it? I just asked your team member, how did you find it working with males in the team? Were you up to speed with climbing the mountains, the hills together with them, or were you left behind? You were feeling like they rush you or stuff like that?
Physically, I was not challenged with them at all.
She can walk very fast.
Exactly,
Oh.
so
No.
no. And Zaid herself, she's quite fit, so we did not feel challenged at all. Actually, we could climb higher than they could.
Wow, that's amazing. So can you tell us? Just asking you these few questions. Which type of compass were you comfortable to use in the field?
I was comfortable with using this one.
Oh, okay, the silver compass.
The rest I don't know how to use them.
The rest you don't know how to use them. So do you think this one is much easier to use, or do you think?
For me, I'm usually the person that if you teach me to use this one,
Mm.
then my mind is already, comfortable with that. And then if you teach me something else, then I'm a bit fuzzy. So first time I was taught how to use this one.
Oh.
So that's why I was comfortable with it. But for other people, they find it more difficult.
Okay, Mels, do you agree with having the knowledge of using one compass makes it easier for you, or you want to have the knowledge of using the variety of tools in the field?
You need to know how to use all of them because you need to be versatile. You don't know which equipment you're going to use when you join the industry next year. You could be using any one.
The question comes, did all of you have the same equipment in terms of compasses, or they gave you different?
We had different compasses and we could teach each other how to use it. Like with me personally, I was used to using a silver compass because I used it in second and third year. And then we had the crowns, and then we taught me how to use the crowns, which I found was much easier to use and much simpler because you can do that direction and that in one direction, which was very, very good.
Oh, okay. Well, guys, thank you very much.
I just have one more suggestion in terms of this field trip for the department. This field trip was unorganized and it wasn't the best field trips. Based on field trips, it wasn't really fruitful. Fortunately, that's no one's fault. I know they tried, but maybe it could be possible if we could have during the year. I know it's going to be a busy semester, but maybe we can have like day field trips during like maybe. It doesn't cost money. We can all take a train and to Worcester and map the Worcester fault or whatever. Just because I feel we're not ready for the industry yet. We've been so limited to field work in our undergrad, and this field trip wasn't really fruitful either. So, if we could have day field trips where there's no accommodation, no food involved, just to have more experience how to use the equipment, how to do geological observations
On our
own and with help. Even if it's, we know obviously around Cape Town it's only a sedimentary environment, there aren't any metamorphic rocks. It's fine, just as long as we have more exposure. Maybe even just a day field trip. There's so much you can learn in a day. If
They have time.
if they have time and if they will take us, we pay for our transport, our food. All we want is just more exposure to rocks and more exposure to field work.
Yeah, more practical work.
And more practical work because it's very difficult for us, because joining the industry next year, I just feel we're not ready at all, Especially like our weakest point is mineral identification. That is a problem for everyone on this class, mineral identification, and that is something that is so important when you join the mining industry or whatever. You need to know your minerals, for exploration. Like most of us are going to go into the mining and exploration industry, and just the knowledge of knowing quartz feldspar biotite, we're going to be in trouble. And even if we can't go out in the field, we can have more pracs, where we look at minerals,
Under the thin section.
maybe thin sections, maybe hand specimens, whatever, but mineralogy is a big, big problem for the students in our class.
Okay, this question comes, I will ask someone else, Andy. Okay, yeah, to draw more emphasis on what he just said. What kind of mineral are you able to identify on the field?
Feldspar, quartz, biotite, what else? Those are the basic ones, like they are easier to spot. Plagioclase as well. Mica.
Okay. Well, what are those minerals that made it difficult for you when you saw them? You're like, okay, I don't know this.
Sillimanite.
Yeah, that. The codorite as well. And yeah.
Garnet.
Oh yeah, the garnet.
Garnet is also something new.
Yeah, something like that.
If someone hadn't pointed out to me, I would have known that was garnet.
But
And
then
Can you guys tell me? Because I just listened to how you guys naming different minerals. There's a question that just came to my mind now. I want to ask you: are we looking at a sedimentary environment, magmatic environment, or metamorphic environment? The question goes to anyone.
We're looking at a mostly high-grade metamorphic environment, but we also have some metagranites, which are basically igneous rocks at the brink of metamorphism, you know. So they haven't completely undergone metamorphism, but they're not purely igneous as well because they still have foliation.
And some
So-
metasedimentary rocks.
And there's a metasedimentary rocks as well, and also a lot of S-type granites. You know, S-type granites have foliation, but they were not metamorphosed. So the foliation was caused by cooling of magma, partial cooling and carbon melting.
And we find a lot of antithesis structures.
Structures, yeah.
Oh, okay. Well, as far as I know, you have two types of, let's say, foliation in a phenocryst or porphyroblast occurring. When I say phenocryst, I'm referring to magmatic rocks. When I say porphyroblast, I'm referring to metamorphic rocks. So you can say if I'm wrong. As far as I know, is that you get alignment of phenocryst in any magmatic rock if there was a certain entrainment. Okay, meaning that when the magma was coming to the surface, right, it was flowing. It wasn't static magma just staying somewhere, okay, and then just come and plume up to the surface. It was flowing. So when it flows, so you get all those elongated minerals such as big cave feldspar that form intrusively. Okay, they can appear as in an eye shape, you know, eye shape, but they are phenocryst instead of porphyroblast. So that is the confusion. So now, and in terms of argon gneiss, you get big porphyroblast, right? Porphyroblast that are randomly oriented in one rock. Okay, and when they are forming, those porphyroblasts often form syntectonically, so meaning that they form at the same time when the deformation occurs. Okay, so you get stress field in a particular orientation, and then that stress field will align all those elongated minerals, and they will occur as porphyroblasts in a smaller matrix, if you want to call it that way.
Yeah.
Okay, seeing that complex, right, in difficulties in terms of explaining, because I know at some point, in terms of magmatic bodies, you refer to incongruent melting. Right? So incomplete melting, where you have you melting one initial body with some composition, and you form a melting product with another product that do not have anything to do with your original product. Okay, so how were you guys able to say, okay, I decide this is a metagranite, I decide this is an argon gneiss, I decide to say this is this. What are the steps that you guys, or what are the people that you have considered?
Okay, first of all, mineralogy, like the garnets, for instance, we know are mostly of sedimentary origin. So we know that if there's a high component of garnet, it must have been of sedimentary origin.
And also the spacing between the banding.
Spacing between the banding as well.
Okay. So how, because to just hear what you just told me now, I'm sensing that we can have foliation taking place on the certain rocks, and we can also have migmatization, right, taking place. So were you guys able to, draw the difference between the foliations and the migmatizations, or anything that was a sort of appealing feature on the surface of the rock, the rocks that you observed? Anyone? Can you?
The migmatized, they were in the migmatite-like rocks
Okay.
that had banding. the leukotratic and metallotratic.
Okay.
That's called an anatexic structures. Those are the kind of other things that we can actually distinguish in the actual case of value. When it comes to distinguishing from magnetite and the touch correlation, it was kind of challenging.
Okay. Do you guys have anything to add? We said it all. So do you have anything to add?
I think everything is good.
Zay, do you have anything to add in terms of, give us some expertise on what you think, how was your experience on being able to differentiate between metamorphose and let's say metamorphic and magmatic rocks, and seeing that, okay, because he talked about A-type granite, right? A-type granite, A-type granite. So it makes me see that you guys were able, once on the field, you can even infer a protolith of the rock that you're observing. If you say it's an S-type granite, meaning that you know it came from the sedimentary origin. Okay? So if you say I-type, it came from a magmatic origin. So that was quite impressive. So can you tell us how was your own experience? No, it's okay. You don't be shy. Laugh. Do anything you want to do.
Want to say something?
No.
Okay.
I have also one comment, like, okay, we did metamorphic petrology in third year. It was basically a semester of igneous, metamorphic, economic, and exploration. It was actually a lot of work, you know. Now, when we were doing the metamorphic petrology segment, like, I really knew the stuff, you know. I knew all those textures, I knew all the fascies, I knew the metamorphic reactions, you know, I really knew those stuff. But now that I'm coming to the field, it seems like I've forgotten all those terms. So it's like almost like I didn't have any depth understanding. It was just like maybe cramming, you know, because I needed to get all that amount of information in my head just to pass the exam. And I feel like it was taught over such a short period of time and so much work that I crammed it, and now that I'm in the field, I can't remember the stuff. And unfortunately, I didn't have time to read up on metamorphic petrology because I was busy with my honours project in Namibia, you know, so I came to Cape Town on Sunday and Monday was a field trip, so.
Okay, when I spoke to your supervisor, sorry, they told me something that some of you guys were up to speed, right? They give you something, you apply, right? And but others were slightly behind. They teach you something, and you still don't know how to apply. And what to just emphasize more on that is that one tutor just told me that he came to find out that a few people do not know how to use the compass. But they had time to ask questions of the field, so they explained to them. And I want you guys to tell me, because you know your classmate, right? You know their level of understanding. In general, can you, in the scale of, let's say 1 to 10, how do you rate the understanding of your class? The level of understanding of your class?
I'll probably put my 6, you know, because, you know, geology is a very practical field, you know. We just did not have enough exposure to practical aspects of geology. You know. Whether it's field work, whether it's lab work, whatever it is, mapping, computer, GIS, we had very little exposure because we were so many in undergrad, you know, it was difficult for practicals, you know, practical components, especially thin sections and stuff like that. We were like 40 people with 10 microscopes, whatever. So it's a matter of the numbers, the problem, you know. It's not everyone's fault. If only we had more exposure to practical components and practical aspects, I think we would be more competent.
Okay.
But,
just on that line, just tell me, How is the relationship between you student, and your supervisor? When they communicate anything to you, was the message clear enough? In terms of you being able to mark on the field, was it like they give you something, you apply, or they have to repeat themselves time and time?
With me and my group too, we never really needed much explanation. Most of us, we came to the campuses, I think it was everybody who needed their minds refreshed and how to use the campuses, but it's like basic mapping and stuff like that. I think we were all,
Yeah, I think
just came to, when it came to certain mineralization, we couldn't identify. That's when it just came into and maybe, helping us to locate ourselves in the map. There's always a challenge when you start with it. Those are the kind of aspects that we did last week.
And also identifying different rocks within the challenge. You see a rock, you know it's a metamorphic rock, you see the foliation, but you can't really say what is the name of this rock. Is it nice? Is it granulite? What exactly is it? Rock! So that is also the challenge. We needed someone to tell us, this is granulite, this is nice, this is metagranite, whatever.
Okay, well, thank you guys. I appreciate you taking your time and being in the short view. And I wish you all the best for your everything that you'll be doing from now on, going back to campus and focusing on the write-up of your report. Well, good luck with your career in the future.
Here's the thing.
Okay, thanks, Mark.